Hello all, my name is Krishna and welcome to my YouTube channel. So guys, today in this particular video we'll be discussing how we can use naive Bayes classifier with respect to text data. Remember, in my previous video I've already discussed about naive Bayes classifier algorithm and I'd shown you some examples with category features and I tried to classify that particular data itself, right? Now, with respect to text data, how does a naive Bayes classifier actually work? Now this was the question asked in my yesterday's video's comment also, guys, so I'm going to explain you over here in a proper way. And always remember guys, most of the text classification like spam classifier, good or bad, or whether the restaurant feedback was good or bad, so those kind of problem statements you have seen in many blogs, in many projects, they actually implement naive Bayes classifier. So we'll also try to understand why it performs better, why we can actually consider it as a baseline algorithm for text classification, and then we'll also proceed in solving this particular example itself, right? So let us go ahead. Now already, if you remember guys, in my previous video I've discussed about Bayes theorem. So this is the formula of the Bayes theorem. Now if you remember, with respect to NLP, right, that is natural language processing, right? So here, suppose my aim is that if I'm given a sentence, I need to find out whether this sentence is good or bad. So good or bad basically means, suppose if I take an example of restaurant reviews, right? Suppose this sentence is a restaurant review comment, okay, and then we need to classify it as good or bad, right? And usually in NLP, what we do is that guys, we perform a lot of pre-processing steps. Like I'll just tell you what all pre-processing steps we'll do. We'll actually try to remove the stop words, right? We will be performing stemming, and we will also be performing something called as bag of words, or you can also perform TF-IDF. And probably many of you will be thinking, I've already uploaded an NLP playlist and that is right now private, guys. Just understand, just give me a week time, because I'm going to create this kind of videos with respect to each and every NLP concept, and then I'll make it public. Just a week time. All these concepts will be explained in this board manner and it will be given to you, right? So after performing all these processing steps, and after we actually create a bag of words or TF-IDF or word to vec, right, we get vectors like this, right? Suppose this is my feature 1, feature 2, feature 3, feature 4, right? These are actually words, the most frequent occurring words, and based on the sentences we can actually, suppose if I'm using bag of words, I'll be getting values like ones and zeros, specifically binary bag of words, okay? So I'll be getting the values as ones and zeros. I'll be discussing about this particular data set. Now after applying all this particular feature, we actually get the vectors with respect to specific sentences, right? And then we will also be having an output feature which says whether the sentence is positive or negative, right, or good or bad. So good is for 1, bad is for 0. Now when we have discussed this, now how do we apply this Bayes theorem? Like now my question is that I need to find out my probability of y as yes, that basically means like good. Okay, so I'm just considering 1 as good, so here I'm just writing it as yes. Okay, so given my sentences, sentences, I need to find out this, right? And remember, in sentences I may have many words, x1, x2, x3, x4 till xn. I may have many words over here. Now I can probably write this as probability of y is equal to yes, right, considering the Bayes theorem, given my sentences, or my sentences which is actually formed with number of words like x1, x2, x3 up till xn, right? I need to find out this. Now according to the Bayes theorem, and yesterday also I discussed it, right, we can write this as probability of y multiplied by, right, this is basically the product of I is equal to 1 to n. So I will write it as probability of x1, right, given my probability of y is equal to s, so I'll write it as y is equal to yes, right, multiplied by probability of x2 given y is equal to yes, and like this up till probability of xn given y is equal to yes. Like this we can actually convert it, right? Yesterday we saw this, and I can write this as directly proportional, because if I write divided by probability of b basically means all the words in the sentences, right? This is a constant if I try to divide it. So I can write my whole this particular Bayes theorem that I'm actually applying to a text data in this particular format, right? Now what is the next step, right? Now understand from this particular problem statement. Okay, suppose I had some sentences. From that most frequent words, with the help of bag of words, I have found out the features as the, food, delicious, bad, output. Output is basically my dependent feature. These are my sentences, these are my features f1, f2, f3, f4. If you know bag of words, we will basically create this kind of features. Now my sentence 1 over here, you can see in the sentence 1 is the food is delicious. So for the, I'm putting it as count as 1, food again 1, delicious 1, bad is 0. Now you may be thinking, where is gone? Is will be removed by the pre-processing step, that is stop words. Okay, so for all these particular values I am getting the output as 1. Similarly for the sentence 2, the food is bad. The food is bad, this will be my sentence 2. The food is also having 1. Now you can see delicious is having 0 and bad is actually having 1. Now you can see that this probability of x1 with y is equal to yes, this x1 is nothing but the words that are present in the sentences. Okay, after the pre-processing, what are the words remaining in the sentences, and with respect to this will be my x1, this will be my x2, this will be my x3, suppose. Now with respect to this particular sentences, I need to find out what will be the probability of yes. So this will be my x1, then I'll try to find out the probability of x2, I'll multiply it, then x3, I'll multiply it, finally I'll go till x of n, how many words it may be. Okay, so I'll be doing this. Now let us go ahead and try to find out how to find out probability of y. Now probability of y is what? You can see that this is my output feature, which is y. Okay, I just have to find out, and since I'm trying to find out probability of y with respect to yes, right? With respect to yes. So with respect to yes basically means I need to find out how many times this, how many number of records are having 1. So you can see this over here, 1 record is having, 2 record is having. So I can actually see 2 counts are there, right? So probability of y is equal to yes, I just have to write 2 divided by total number of records, 1, 2, 3, 4, 5. I'm just taking this as an example. So my this probability of y is equal to yes will be nothing but 2 by 5. Now the main task is multiplication of probability of x1 where y is equal to yes is given. Now go and see for x1. Now x1 over here for this sentence is the. See where the and the output is 1. Right? So over here you can see 1 count is there. You cannot see any other values, right? Where the and output is 1, right? Because here we are saying probability of x1 with y is equal to x. So you can see that the is present here and the output is also 1. So I will take this 1 value divided by, just let me write it over here. This is probability of x1 where given y is equal to yes. Now suppose this will nothing be equal to 1 divided by how many times the is present? 1 and 2, right? 1 and 2. This is nothing but it will be divided by probability of x1, right? So x1 is nothing but the, 1 and 2 sentences the is present. You cannot see anywhere the. So this will be nothing but 1 by 2, right? Now similarly, let's go to the second word, that is x2. In x2, the food is present 1, output is 1, right? Only 1 time it is present. Okay, 2 times it is present over here and over here, right? 2 times the total count is with respect to both 1 and the output is 1, right? Probability of y is yes. So I will write like this as probability of x2 given y is equal to yes. Now you can see that probability of x2, that is my word 2, that is food, where it is present as 1 and the output is also 1. It is present 2 times. So it will be 2 divided by how many number of times food is present? 1, 2, 3, 4, right? So this will be nothing but 2 by 4. Like this, I will also go and find out for the word delicious. Now delicious, how many times it is present with output as 1? 1, 2, right? 2 times it is present. And how many times delicious is present? 1, 2. Again 2 by 2 is nothing but 1. Now when I go and compute this, suppose this is like 2 by 5. You can see this 2 and this 2 will go 1, 2. And this 2 and 2 will go. So the total value is nothing but 1 by 10. Now 1 by 10 is nothing but 0.01, right? 0.01. Now in this particular case, suppose this is the value with respect to probability of y is equal to yes. Similarly, we have to go and compute with probability of y is equal to no given my sentence. And I have to follow the same step, right? Same step, but here I have to just calculate probability of y is equal to no. Right? How many times no is present? 1, 2, 3. 3 divided by 5, right? So this will be 3 by 5 multiplied by all the values you have to see with respect to no, right? So suppose if I take the example of the, right? over here you can see the and output is present over here. The output should be 0, okay? 1 and 0 is present over here, and nowhere it is present, so it will become 1 by 2, right? Because total number of ones is 2, and you can see with how many times the output is negative, right? That particular count. So similarly, you will do the multiplication, you will be getting some value. After you get this particular value, we basically normalize this to 1. How we will normalize this to 1? Suppose I got with respect to probability of y as no with respect to the sentence this much value. If I want to convert this into, if I want to normalize this into 1, I will just have to write 0.01 divided by 0.01 plus 0.03. So this will this will be actually 0.01 divided by 0.04. Now you can just see that it is 1 by 4. 1 by 4 is nothing but 0.25%, right? Now in this particular case, I'm just taking in this as an example, guys. Okay, so 0.25 is nothing but probability of yes, and if you want to find out probability of no, it will be 0.75, because 1 minus 0.25 is 0.75. And again, guys, I've just taken this value as 0.03. Okay, I can also take it as, I'm just computing it, you know, I'm just randomly guessing, okay, this much it may come, but usually for this particular sentence it should be true, right? So this particular value will be higher, 0.75. okay, somewhere consider that a probability of yes I got 0.03, in this I got 0.01, then 75% will be the probability of yes. Now whichever will have the highest probability, that will be considered as the output of that particular feature or that particular sentence. Okay, now the most important thing, guys, I hope you have understood with respect to NLP. And remember, for all the text classification in machine learning, it is always better to go with naive bias, because over here the probability of each and every word is checked, right, with respect to the features that you have. Apart from that, also the probability of output is checked, right? Here you can see the probability of output is getting multiplied. Now where does this fail? Okay, I'm just going to give you some scenario. Suppose in this particular sentence I have a new word. Okay, I have a new word. Suppose the food is delicious and tasty. Suppose if I'm going to find out like that. Now tasty is a word that is not present over here, and definitely for that probability, if I try to find out, the value will be 0, right? Now if I have value as 0, this whole multiplication will become 0. That basically indicates that by default this will be treated as the negative output. So how do we solve that? And one more scenario is that, suppose what will happen if my data set is imbalanced. So all these particular topics will be covered in the next videos, guys. I'm going to again explain you in depth. So please make sure that you follow this particular series, and I hope you have understood this from this particular video. Please do subscribe the channel if you are not already subscribed, and I'll see you all in the next video. Have a great day ahead. Thank you one and all. Bye bye.